Hello and welcome to a new webinar. My name is Nicholas Oppenberger, Product Manager at UWT, and today we are focusing on the chemical industry, the chemical sector, and for that reason I invited our expert, Valéry Kemtchou. Hello, Valéry.
Hey, Nicholas. Yes, from my side as well, I would like to welcome you. And today we are going to take you through the chemical industry and the expertise, the competencies of UWT in that sector. And by talking about chemical industry, it means not only the company which are producing chemicals, but company which are dealing with chemicals as their reactant or as their raw material. Yes, like fertilizer or pharma industry, for instance.
Yeah, Valéry, thank you. As I know, you are the expert, and when I'm thinking of the chemical industry, I always think of dangerous atmospheres, aggressive materials. So could you give us, please, a little bit more detailed insight about the requirements and the challenges waiting for us in the chemical industry regarding level measurement?
Yes, well, Nicholas, I think the first or the main thing in the chemical industry, or when you are dealing with chemical in the industry, is the safety. That is why for us, we pointed out here, having the right safety level is very important for your process, first of all, for the functional safety, because the functional safety is protecting your personnel for exposition to hazardous product or conditions, and yes, even the material damages when something is going wrong in the process. Yes, that is the first important thing regarding the challenges, and the second is the reliability of the measurement in difficult process condition. Yes, and we have from one side the process condition, and for the other side the material condition. But I think Nicholas is going to give you more detail regarding that. And what I would like to point out here, Nicholas, is when we are talking about level measurement, we have reactors and we have storing devices. And then another point is the interface measurement in the chemical sector, which is very important. Yes.
So we also prepared some slides for this requirements that you already mentioned. So maybe Igor. So here. So this was
exactly, that is exactly what I have explained. You see the challenges, and then you see from one side the functional safety, and then the other side the reliability in difficult conditions. Yes, and yes, maybe here having a look on the functional safety, it's very important, the proof testing of the sensor, because at the end of the day, it's very important for the customer, for the client, to protect the personnel who are working in the plant. And on the other hand, as I mentioned, the damages, the material damages that could happen if the sensors are not working well, if something it's happening there, like a cable break or something there. That is why the functional safety is very important. And there are solutions, UWT solutions, which have been developed to master that, to offer a resistant and a high quality functional safety. And here, Nicholas, we have, for instance, SIL2, which is like a continuous monitoring, yes, of of the function of our sensor, as well as this homogeneous redundancy, which is very important. And Nicholas, what do you think? What are the specific UWT product having that safety integrated level 2, which is SEAL 2?
Yeah, as you mentioned, the chemical industry, always a requirement or often a requirement is the SEAL 2 functionality. And for this requirement, UWT offers 3 different units. So we have one continuous level transmitter. So this is the Nivo Guide, our guided wave radar level transmitter, and then 2 level switches. So one specialized on a liquid application, the Kappa Nivo 8, and the Roto Nivo also comes with the SEAL 2 functionality or certificate.
Okay, it means here we can UWT can cover liquid and solid.
Exactly.
Both. Yeah. That's good.
Also point level and continuous level.
Okay, that's good.
So here to point out what you already said, so reliability is a big issue for the chemical industry. So, and here we have, what is meant with reliability. So we can classify it in 3 different classes. So we have the material conditions that are challenging. So we're dealing with aggressive materials, with adhesive materials with a high viscosity. So they might tend to build up, and also with build up, even with build up, the sensor should perform reliable. And another big issue regarding the material conditions are the changing properties like density. So we have density changes the material in the chemical application in the chemical industry. The second class are the process conditions. So often we have agitators inside the tanks, and those agitators, they cause a lot of turbulences. What is also a big challenge for our sensors regarding the stability. And the second point are the changing conditions like temperature, so temperature changes and also pressure changes. Installation can also be an issue, so difficult or limited spaces, so difficult installation positions, conditions, mounting of sockets might be an issue. Then often we have installation inside the tanks like stilling wells or heating elements, and it's also required to install the sensors in pipelines. So we need a short immersion length or different solutions to solve also the measurement tasks in pipelines.
Yes, that is very interesting. You see, that is a topic which is very wide, which is very broad and even widespread in the industry. And we are going now to move to, let's say, the practical part, to the concrete part, and we are going to take you through some application that UWT has really pretty well solved. And yes, the first one here will be the production of aluminium sulfate, and in that process, high concentrated sulfuric acid is needed, and the task was to find a sensor, a level sensor, which can detect the presence of high concentrated sulfuric acid in the tank. And it was coupled with many challenges, like, acid, high concentrated acid is high corrosive, high abrasive. The same, it was like a pipe, and the place to install, to mount the sensor was very small, and at the same time the process connection was also small. And by talking about challenges, it's the opportunity to show what we can do, and I think UWT did the work, right?
Yes, we did the work, and we did the work with our new CN7 redesign series. So for this application, yeah, we installed our new Kappa Nivo 7121, so the complete plastic version. Yeah, here we had a lot of challenges coming together. So narrow installation space means we need a short immersion length. Yeah, we need a short or a small process connection, aggressive material. So we need resistant materials. Here, our complete sensor is made from PVDF. Yeah, easy to set up, so user-friendly setup. It's easy plug-and-play sensor. And here, our new CN7 was really the perfect solution for this type of application. And as you know, we recently launched our CN7 series. So I want to go a little bit more into, not too deep into detail, but to give you a short overview of what our sensor is made of, what the specification is. So here I would talk a little bit about the 7121 version. So it's resistant for many applications with aggressive materials because it's made out of PVDF, so really resistant material. The whole sensor is completely synthetic. We have two types of process connections, so 1 inch or 3/4 of an inch, so we can fit in different type of holes. We have the short immersion length of 92 millimeters, and also different type of electronics of signal outputs. Either you need a relay or transistor, or 816 milliampere signal, or we have even the continuous mode if needed. So here, this is the new CN7, perfectly designed for the aggressive materials, for aggressive atmosphere. And in this application, it worked really good.
That's good. That's good. Thank you, Nicholas. Now you're going to move to another field. As I mentioned at the beginning, chemical industry is very broad, and now you are going to the petrochemical industry or field. And there, the challenge was to measure the level continuously of petroleum product like diesel, kerosene. And it was also here many challenges like the mounting conditions. The sensor should be mounted in a steel wheel. That was the condition of the customer. And then even the risk of explosion, you know, petrochemical product like diesel, kerosene, they have a high risk of explosion. And then even here we had the commitment to offer a high performance level sensor, as well as the accuracy. Yes, should be high. And Nicholas, how are we? Do we have? Let's see, manage that application.
Yeah, for this application, we installed our Nivo guide, our guided wave radar transmitter, which you can see on the next slide. So this was the perfect solution because we had a stilling well. So we had to mount the sensor in the stilling well. This is what you can see on the picture here. And the stilling well has the same effect as a coax version for the Nivo guide. So all the energy is focused inside the stilling well. So perfect conditions for the Nivo guide to measure the level, reliable, and it has all the X certificates. System materials, stainless steel, and here we used the rod version of the Nivo Guide 8100, our guided wave radar level transmitter for liquid applications.
Ah, that's good, pretty well. And yes, now you're going to go to another field, which is, let's say, very special. That is the veterinary sector. And here we have a a reactor. You can see there with buffer for agitation, and even here the temperature was high in the reactor, and the task here was to measure the level of product, yes, veterinary product inside that reactor. And to the change, we can even here add the hygienic because in that sector, veterinary is very important to have hygienic material and yes, to ensure really the high quality of the product. And I've already mentioned the high temperature, and a key point here or a main challenge here was the turbulences, because in a reactor, by mixing, you need to agitate the product inside the reactor, and at the same time, it should not disturb the measurement. The accuracy should be kept high as well as the performance. Yes, and I think here UWT, let's say, has offered something special, Nicholas.
Yeah, Valerie, thank you very much for this application, because there are so many things we can explain. So first point, we use the Nivo guide here in this application, and there are really a lot of things. Yeah, what we can talk about. The first thing you see on the left picture. So we use the Nivo guide with the coaxial as a coaxial version, with 3-clamp process connection. So we had also a little socket here where we had to mount it. Then we had heating elements inside the tank. So you can see it on the right side, on the right picture. At the bottom, we had to fix the coax version to fasten it at the tank wall. And why we did it, we have 2 videos. What you can see here, so we have an agitator inside the tank. So here you can see the blades, and on the left side you can see our coax version that is really mounted near the tank wall, and also the blades are not far away from our unit.
Okay.
And the other pretty challenging condition was that we had the agitator. This is what you can see, and all the turbulences inside the tank. So what we did, we had limited space and the turbulences, so we needed the coaxial version, because all the benefits from the coax version. So the energy is focused inside our coax tube. So this is important to get no false signals from the agitator and maybe also from the tank wall, because we recommend to mount it a little bit far away from the tank wall. But with the coaxial tube, there is no need to care about any installation limitations, agitators or things like that. The other effect was that we have inside our tube, we had these turbulences inside the tank, and with the coaxial tube, the surface inside this coax tube is calmed. So we get a reliable measurement results. We do not have the effects of waves or of this turbulent surface inside our tube. So the surface is calmed here. It also protects the unit. So we have a more stable probe here with the coax tube, and it can be easily fastened.
Maybe stop you, because we have seen the video there with the agitation, those turbulences. Do you mean the measurement there was really high accurate? Because those turbulences, they were really strong.
Yes.
That is wow for this.
So due to this coax version, so we have a calm inside our coax tube, so the surface is not as turbulent as outside. So here we get a pretty stable measurement with our Nivo guide. And the next point, because of these turbulences, we had a longer coax tube. Maybe it could be damaged, but here we fasten it near the vessel wall. So And always I get the question how to fasten the tube. So this is always a bit challenging, and is there a conductive connection? So this is what we can see on the next slide. So here are some recommendations. Here you can see some pictures of how to fasten the tube. On the left side, on the vessel wall. This was the application we already explained, and on the right side you can see one example from a solid application. This is how they fixed the rod version here. To give a short recommendation, we go to the next slide. Here we have a two recommendations of how to fasten the probe. So what we recommend is that we have an isolation between the tank wall and the probe, maybe the coax version, maybe the rod version, maybe the rope version, so that we have an insulated part. So recommendation 2, you can see using 2 eyeballs and then an insulated cable to fasten the rope version. Or on the left side, the recommendation number 1 is with a threaded rod. This is screwed inside our sensor wide, and then using a plastic element to insulate the silo well from the rope. This one is fastened with a lock nut, and then we have the insulation between the sensor weight and the silo wall. So these are the 2 recommendations we give if it's necessary to fasten the probe of the Nivo guide.
Interesting. It means UWT has 3 versions of Nivo guide, because you mentioned here Nivo guide with the rod, and then Nivo guide with coax, and then Nivo guide with rope. That is very interesting. Yes. Okay, now then we are going to move to the next beautiful application. Here it was acid, hydrochloric acid, and the challenge was here to measure the interface, in a form. And as I mentioned at the beginning, interface measurement is very widespread in the chemical industry, because when you have interface, you are increasing the surface of reactions. And at the same moment, it's important to know exactly where the interface is, where is the level, what is the level of the interface. Yes, and here it was aluminum hydroxide. Yes, and the challenge was aggressivity of the acid, and the same with the fast response time. That is what the customer it was the commitment of the customer, and even the high accuracy, because for the customer it was very important here to have a sensor, a solution which is high accurate. Yes, and even here, because we have seen UWT is always present where the challenge are very high, and I think even here it was the same. Nicholas.
Here we had this, like you explained, the aggressive environment. So we had to solve this application with a little bit of special version of our capacitive level switch, the Kappa Nivo 8100. So as you know, we have this little tube element made out of stainless steel, and also we have a stainless steel flange process connection. And though stainless steel might not be resistant enough for this application, so that's why we coated our stainless steel part with PVDF. So we had a coating around our rod and the probe. So the measuring part of the Kappa Nivo is made out of PVDF. So we had the resistancy here guaranteed with our coating and with the elements using for the measuring part of the sensor. Then we have again the tip sensitivity, perfect for application with foam, fast response times, so it reacts pretty fast. And we do also have the easy calibration setup, so you can adjust the sensor to the foam to ignore or to detect the foam. In this application, we had to detect the foam. So the Nivo the Kappa Nivo worked perfect in this application.
And I think here even the process parameter, they were not stable. They were changing, and as you can see, even that special challenge was, let's say, mastered using the Kappa Nivo.
Yes, because you can adjust it so easily and to the different process condition. This is also the big advantage of capacitance level limit switches. I have it here so that you can see our sensor. So here you can see this is how it normally looks, what you can see on the slide. We have the stainless steel element, and when we have acids or aggressive materials, then we can offer this version where we just coat the stainless steel element, and we also coat the flange.
That's why it's black, yes.
That's why it's black, exactly. Okay. So this is the coating of the sensor, and with this unit you can also solve application with a pretty aggressive environment.
That's good. Very interesting. Okay, now we are going to move to another classical in the field of chemistry, chemical industry. It's liquid ammonia. It's a very challenging material because it has different features. The property can change during the process. And here it was, the task was the measurement, the level measurement of liquid ammonia. And as I mentioned, it's a volatile gas. And even here, the customer for the safety, the functional safety, SEAL2 was a requirement here. And even the high sensitivity was very important. And another challenge was the difficult installation condition. And yes, that is a classic also for UWT. And yes, the response was?
Again, it was the Nivo guide that we installed here. So we had a bypass installation, bypass as well as stilling wells, the same effect as a coax version. So here, stable measurement results. We have the SEAL2 certificate for the Nivo guide, and also we have the slot. It's the second line of defense, so a special sealing design for our Nivo guide, optimized for ammonia application, as you mentioned, so volatile gases. And here Nivo guide works perfectly. So what I want to focus on are the toxic gases, aggressive vapors. What makes the Nivo guide special for those two type of challenges, because maybe a normal sealing design is not sufficient for toxic gases, and also aggressive vapors, we do need special sealing versions
to protect the housing, the electronic.
Exactly. And this is what you can see now on this slide here. So here we have a cut model of the Nivo guide 8. You can see the second line of defense, the upper part of our sensor. So this is this additional protection, this additional sealing. It's borosilicate glass feeds through this second line of defense, and it just stops toxic gases from entering the housing. And so we can guarantee a safe operation also for the workers. And on the right side, we do also, for aggressive vapors, need special sealings. So the normal standard sealings might not be resistant, and for those extreme aggressive environments, we have our FFKM sealing. So inside this little coupling here, and also the chemical resistant peak condensate cone on the lower area. So as you can see, a NeoGuide is also perfectly designed for those applications where it's pretty challenging.
Oh, that's very interesting. Yes. And now I think we are going to discover another solution, UWT solution, which is also pretty nice, like NeoGuide. I think with the next application here, the task was to measure the level of high concentrated sulfuric acid, and the challenge was let's say the high corrosive effect of the acid. The acid is aggressive, and even here the accuracy was very important to know exactly the level in the tank, and even the response time should be very fast. And here what at offer UWT.
Here we installed our continuous radar level transmitter, so the Nivo Radar 3100, the non-contact radar transmitter that comes with a resistant lens interior. So it's made out of PEI. We have a stainless steel housing, and we do also have this polyethylene powder coated flange version. So here the Nivo Radar measured perfectly in the vertilizer. So also Nivo Radar can be used for the chemical industry, for the chemical sector.
That means not only NeoGuide, even Nivo Radar in non-contact level transmitter.
Yes.
Wow.
And
many options.
And also we have one accessory for the Nivo Radar when it comes to even more aggressive environments. So we have the Ptfe protection plate, which is mounted below our normal flange here. And with this protection plate, the process connection is then even more is protected from this aggressive environment, and also the lens antenna. And one thing to mention for this plate, it's really made for our Nivo Radar, so it has a certain thickness. So this thickness is adapted to the transmitted frequency, so that we do not get any interferences from this plate, and installed it in many applications, and it worked pretty well.
Okay. Here, this flange is black. It means is it a coating?
Yes, this is polyethylene coating.
Ah, okay. Yes, you mentioned that. It means here normally when we have a boat, it's like you can see it's like a double safety that we offer.
Exactly.
To
exactly,
the process.
And it's also easy to remove the plate, so and just change it out, and you have this additional protection of the Nivo Radar.
Ah, interesting. I think yes, we can really see how broad the solution of UWT are, and I think we are going to have that continuation in the next application. Yet here we had additives, and the task was the level measurement of liquid paints, and those liquid paints, yet they have features like built up. It means they have the ability to stick on material, and here when you have a sensor, a probe there, they would stick on the probe. And now how it's possible to measure, to detect the level, or to measure the level, and at the same time the aggressivity, and because some of them, they are very aggressive, and here UWT it's at home.
Yeah, I see that. This is correct. So build up Yeah. Um, new RF Nivo 3100 with active shield technology. So this helps to ignore all this build-up from the paint, and we do also have this quick response time. So with our capacitance level transmitter, so they are reacting really quick. They are really accurate. They are easy to set up, easy to calibrate. So especially our RF Nivo 3100 with the automatic calibration. So it's just one push button, and then the sensor is perfectly calibrated to the different application conditions. Also, one important thing is the modular design. So you can configure the sensor to whatever you need, whatever the installation condition looks like. So you can vary the length of the active part, of the inactive part. So there are a lot of options. We do also have the resistant materials, so resistant isolations. And as a special version, we do also offer the RF Nivo 3100 with the coating here. So this is, you can see that we have a fully coated extension here. So Ptfe coating, and also a little plastic element made from Ptfe. So this is an additional threaded element that you can screw in.
Okay, and that coating, a question maybe, that coating here doesn't affect the active shield technology?
No, it has no influences on the measuring principle, on the accuracy of the active shield. So it just ignores our coating and still works pretty well. So yeah, we used this type of sensor with the coating, especially for flue gas cleaning processes. So where we have hydrochloric acid, so here aggressive material, and then we're using the coating. And we do not only have the threaded version here, but also a flange protection plate, comparable with the one from the Nivo radar. So if you need a flanged process connection, we can also offer a solution.
Okay, and that is a point level. That is for to detect the presence of the material here. In that case, liquid paint.
Yes.
Okay. Thank you, Nicolas and Nicolas. Yeah, and I think we are going to move to the next sticky material, and that is latex and liquid latex. And the task here was the detection of liquid latex. And yes, I've already said that latex is sticky, and here the customer, it was very important for the customer to have a maintenance-free operation by using the level sensor and a long lifetime of that sensor. Yes, Nicolas, what was here the solution?
Yeah, here again, RF Nivo, but this time the RF Nivo 8200, so the one for the liquid applications and the one for the higher temperatures. So this is what we used here. Has also the active shield technology, the inverse frequency shift, to give it a very high sensitivity, so then it's easy to adjust. When you have build up, then you want to ignore the build up, you have to adjust the sensor. This is really, really simple with our sensors due to the inverse frequency shift technology, and again, the fast response time. So capacitive technology always present in the chemical industry.
Good. Yes, that is that's very interesting, and I'm quite sure our, let's say, our customer, UWT customer, they are quite satisfied with what we are offering. Yes, the different solution. Okay, and now yes, we are going to a field from liquid now to solid, and that is the tires production. And the task here was the detection of carbon black and silica. And even here, it was coupled with challenges like the sensor should have a high sensitivity, and the density of the material, carbon, black, and silica, is very low. That is a challenge, a big challenge. And the process, they were there in the process, a pressure and even dust, because those small particles, they are creating a dusty environment. And even where there are many challenges, I think UWT is there, and I think even here,
UWT is there, and also the Rotonivo is there. So we can also find it in the chemical sector, of course. So also here we have the Ptfe sealing, so resistant materials. We have stainless steel shaft and pedals. So for this application, the sliding sleeve was important because they want to adjust their switching point for different conditions. So that's why we implemented the sliding sleeve, and with the sliding sleeve we had to use the pipe extension so that you can really adjust your switch point wherever you want it. And yeah, Rotonivo always working perfectly also in the chemical sector.
Interesting. That is, it means quite all UWT solutions are very suitable for the chemical industry. When I see those nice applications, yes, high demanding application,
all rounder.
Yes, all rounder. Yes, okay. Then let us move to the next high demanding application. The task was here, like to detect something which is not suitable for the process or the production or the product. Yes, it was foam, and the customer really wanted a sensor that can detect foam, and then to be able to remove, like a foam alarm detection, to remove that foam from the process. And here, apropos challenges, here even we had difficult installation conditions. The temperature was high, and also something which is very widespread in the chemical industry, the changing, and that we mentioned that at the beginning, the changing process parameters, or in that case, the changing material parameters here. And yes, what was here the proposition or the solution of from UWT? Yes.
Here the solution was the RF 8100. So yeah, the customer wanted to detect the rising foam inside this pipe, what you can see on the picture, and we had to mount the sensor on the inside the pipe on the right side, so a little bit angled. And yeah, it was not easy, but with our modular design we found a solution here. So as you know, you can vary the length of the active shield, you can vary the length of the active part of the RF 8100, and you can easily adjust the sensor due to the high sensitivity. So it's easy to adjust. If you want to measure foam, so also with changing properties, so just it once, and then you will get a reliable measurement result. So, and for this application, the customer was really satisfied. So we had no issues with the RF Nivo, although this application is pretty challenging. Narrow installation space, foam, rising foam, high temperature, but the RF Nivo 8100 did the job.
Oh, that's very good. And maybe what I return from those applications is UWT doesn't only offer standard solution. I've seen many customer tailor-made solutions. That is very impressive because as we have seen in the chemical industry, it's not something that you can standardize. Each process is different. You have different parameters that could be changed or that could change, and even the material conditions. And it means there's a kind of flexibility, and at the same time, the quality remains the same. It means high, very high, because that is, I think for me, it was very interesting to see exactly how far UWT is mastering chemical industry challenging or challenge. And yes, I'm very happy for your attention, Nicholas. Thank you very much.
Thank you, Valéry.
Yes, for this nice introduction into UWT solution for the chemical industry. I hope you are going to stay connected to our channel. We have a YouTube channel, and even on LinkedIn. Stay connected, and it's until today.